Hey, what's up guys, JP here, and tonight we're going to do a video that I've been wanting to do for a while, but just haven't had an opportunity to do. Something a little sciencey, but you know I love to not play with fire, but let's say experiment with fire when I have a chance to, and I'm also kind of a do-it-yourselfer type guy. I work around the house, work on my own cars, stuff like that, so I have a lot of different chemicals around the house that I use for certain things, stuff like WD-40, PB Blaster, just different chemicals. So I'm going to try several different chemicals that I have around the house. And I just want to kind of test them, do a little, it's not exactly a super scientific test, but just to see how each one, how flammable it is and how it burns compared to the other chemicals. So let's see, in total I have, let's see, the chemicals we're going to be testing today are, instead of bringing them to you, I'll bring you to them. How about that? How do we do that? Let's see. We have this right here, which is CRC QD contact cleaner for electronics. We have PB Blaster penetrating catalyst. We have the PB Blaster PB50 multi-purpose lubricant, which is like Blaster's version of WD-40. We have some, speaking of WD-40, we have WD-40 as well. We have a WD-40 Specialist Silicon Lubricant. We have BRAKLEEN, non-chlorinated brake cleaner. And we also have gasoline. And I also have a fire extinguisher, just in case. But I don't think we'll need that. We're just going to be using small amounts of these chemicals here just to see how they burn. I'm going to set you back right up here so you can see where my little spot where the burning chemicals are. Now I'm going to use a wood match to light the flame, and we're going to be just looking at the color of the flame and seeing for completeness of burn and how much of residue is left over. I got a watch glass here to put the chemical on. The first thing we're going to try is, well, gasoline. Oh, just a little bit. So be careful, I don't want to pour too much on there. It's one of those safety jerry cans here that you have to like push down on it when you pour. There we go, there's a little bit of gas. It's probably even too much, to be honest. Just pour a little bit on the ground. All right. Now I got gas on my hands, so we don't want to wear these gloves while we're... Actually, instead of a wood match, I think I have a better idea on how to light this. Use the good old propane torch here, that way I can keep a little bit of a distance on it. Just a real low flame there. We'll just go ahead and light that up. And there we have the gasoline burning. Just see how long that burns for. That was about, wasn't that much gas. I would say, oh, I don't know, maybe a fluid ounce, maybe not even an ounce, maybe half an ounce, or honestly probably even like a quarter of an ounce. Not much at all. You say a shot glass full is 1.5 ounces, I'd say yeah, probably about maybe a quarter to an eighth of an ounce of gasoline there. Yeah, it looks like it's just about burned out there, the gasoline, and that's just regular 87 octane unleaded gasoline. And as you can see it burned pretty completely. There's a little bit of carbon residue left on the watch glass, but not a whole lot. Let me go ahead and wipe this off here. I just got a shop rag right here. I'll wipe that off. Yeah, it's pretty warm, that watch glass, so it burns hot, but it burns pretty efficiently and has very little carbon residue left over. And that's what we want to see. That's what you want to see for any kind of, especially something that you're going to be running your car off of, right? You don't want a lot of carbon deposits when you're burning stuff in your car. So now we have a clean watch glass again. I'll go ahead and put this back up here. And next, let's try. This is the QD electronics cleaner. This is mostly hexane and has difluoroethane in it and pentane. So we'll just spray just a little bit of that on here. Go ahead and get our torch there. Give that a light. That's the contact cleaner. All right. Let's try that one again. I'm going to spray just a little bit more of that. Light it quicker. Oh yeah, there we go. That's a little better result on that. This just, excuse me, this stuff just evaporates so fast. You can tell it's very volatile. But it doesn't burn like super hot either. It's not a super intense flame. Alright, looks like that's about to go out there, so let's see, where'd my shop rag go? There it is. Alright, we'll pick this up here. See what it is. As you can see, that burns almost to completion with no residue left over. So those hexanes in there, pentanes, they burn almost completely, leaving almost zero residue behind. That's why this stuff is good for cleaning electronics. It doesn't leave any residue. It completely evaporates and doesn't leave anything behind. All right, next we'll try just plain standard, it's been around since the 50s, water displacement Formula 40 or WD-40. These are propane distillants in here. Or not propane, or petroleum distillates in here mainly. This is penetrating oil slash lubricant of sorts, but not really. Anyways, we'll give that a couple good sprays there, and then just hit it with a torch and see how that burns. And well, as you can see, that's not burning very well at all. That will not sustain a flame. WD-40. Let me try to spray even more on there and see. Yeah, well, now it's going to sustain a flame. But yeah, that's not, unlike the gasoline and the QD contact cleaner, that is not super volatile. You really have to get it pretty hot before it sustains a flame. Now, don't try this at home, kids, but I just want to see. Yeah, aerosolized, definitely a lot more flammable, but just having a pull of it around, you could probably drop a match into it and it's not going to just burst into flames like gasoline or other stuff would like that. And now the WD-40 is completely burned out. And as you can see on here, that just left a mess. A lot of residue, really oily residue left on behind from that. In fact, I'm going to switch out watch glasses because I don't want to. I'll wipe that down in a few. Maybe we'll use that later. But I have a clean watch glass here. Just a clean watch glass. Next, because I'm curious, we get this one over with. I think this one's going to be probably the most volatile. This is BRAKLEEN, brake parts cleaner. This is mostly acetone with some other ingredients in it, heptanes and the like, but mostly like 90% acetone. So got to be careful with this stuff. This is pretty nasty. So I'm going to put my safety goggles on just to spray this one because, yeah, this is nasty stuff. I don't want to get in my eyes. All right. Just a few sprays there. Make sure that can's well out of the way. And CRC BRAKLEEN. Yes, that's very volatile. It ignited almost immediately when it came in contact with the flame. And it burned very quickly, very vigorously. So if you're ever using brake cleaner, do not get that around any sort of flame. Let's see how it fared as far as residue. That one also, like the contact cleaner, burned almost to completion without leaving hardly any residue at all. No carbon residue. There's a little bit. You probably can't even see it on this camera. A little bit of residue right here on the watch glass. Probably some of the just stuff that you unburned left on there, but otherwise completely dry, unlike the WD-40, which left a whole huge slick of oily stuff on the watch glass. Next, we'll try the PB Blaster Catalyst. Now, this is the PB Blaster penetrating oil, not the PB50, which is the PB Blaster lubricating oil. This is the penetrating oil. It says on the can for both the PB50 and the PB Blaster penetrating oil that it's just petroleum distillates. It doesn't give any specific ingredients, so we'll just give it a shot. All right, 2 little sprays there, and hit it with a torch. And like the WD-40, it's not wanting to ignite. It does burn when in direct contact with the flame, but as you can see, in fact, this is even less volatile than the, and I don't have much wind going on right now. Slight breeze maybe, but not a lot of wind at all. As you can see, yeah, it just does not want to stay ignited. So I guess as it should be. I guess the WD-40 and the PB Blaster and the PB50, those are considered more safe chemicals to handle. They're just mainly like light lubricating oils. There's nothing like seriously volatile in it, like with the BRAKLEEN, which has acetone in it, or the QD cleaner, which has like hexane and pentane in it. Very volatile stuff. All right, next, let's go ahead and wipe this off, and then we'll try the PB50. But I am expecting, I'm going to switch watch glasses again. Another clean watch glass here. We'll just move this one out of the way. Give this. In fact, I don't even think this one is going to warn the light at all. Uh-oh. Oh, there we go. That was inappropriate. Here we go. and I was correct. Well, actually, this one seems to be maybe a little more volatile than even the penetrating oil is, but still took me a good minute to get that to sustain a flame. But as you can see, again, it's gone out quickly and left, like the WD-40, a huge mess of hot oils. Oh, it has an odd smell to it too. I think they like scent it, because when you spray that stuff without it being on fire, it kind of smells like vanilla-y. So I think they scent that for some reason. Last but not least, we have WD-40 Specialist Water-Resistant Silicon Lubricant. So we'll give that a shot. I just need another watch glass here. I have to wipe one of these off here. Let's just give this one a good wipe down. Get all that oily crud off of it from the PB blaster. And I guess if I didn't say this before, I'm going to say it now. Don't try this at home, kids. I kind of sort of know what I'm doing, and I do have a fire extinguisher there and safety glasses. So yeah, don't try this at home. Do not light any chemicals, flammable or otherwise, on fire. Last but not least, this is the WD-40 Silicon Lubricant. And that looks very similar to the PB50 as far as the consistency of it. And again, this one is not wanting to burn. There we go, we got a sustained flame, but yeah, quickly goes out. All right, well, that was our experiment with fire for the night. And I think basically the conclusion is lubricating oils do not make good fuels for fire. I guess we could try one last thing here. I do have something, a surprise special guest, grill time, charcoal lighter fluid. I don't know exactly what's in this. I'm assuming stuff like probably naphtha, which is the same stuff they put in Zippo lighter fluid. But if you've ever used a charcoal grill before, you know this stuff burns pretty well. And let me go ahead and just put a little bit in there, like that. And this is probably going to be similar and maybe even more volatile than the gasoline. So let's go ahead and put on the safety goggles. And we'll end the video with this one here. Charcoal lighter fluid. Yeah, there we go. That's burned pretty good there. This was JP. I know I haven't posted a video in a while. Hope you enjoyed this. Something that I've been curious about, just how flammable these chemicals are. And well, today we found out. So if you want to start a fire, use gas, or use even better, there's charcoal lighter fluid here, because this stuff throws off a lot of vapor, very volatile, has a lower flash point, and it's going to light quicker, and it's going to burn longer and more vigorously. It's going to put off a hotter flame. So, and don't play with fire, kids. This was for scientific purposes only. I'm not playing with fire. Do not try this at home. All right. This is JP. Hope you enjoyed this video. Signing off.